51 Introduction to Operating System. The topic is Storage Management, presented by Anuja R. APCSC, Rohini College of Engineering and Technology. Mass storage system. We know that there are different types of storage devices which are present in operating system. Now we are going to learn about each and every mass storage device in detail. But before learning about them, let us know about what is a primary and secondary memory. The first one is primary memory. A processor or computer initially or directly access primary memory while using a computer. It enables a processor to access programs and services that are now in use and temporarily stored in a particular area of memory. Then secondary memory. Secondary memory is non-volatile permanent computer memory that is not directly accessible by a computer or processor. Data that can be quickly and easily retrieved, transmitted and utilized by applications and services can be stored by the user and then used in this manner. The next one is mass storage structure. The system designed to store enormous volume of data are referred to as a mass storage devices. Massive storage devices are sometimes used interchangeably with peripheral storage, which is the management of bigger volumes of data that are larger than the native storage capability of a computer or devices. The basic idea of mass storage is to create a data backup or data recovery system. The mass storage structure devices are, there are three different types of mass storage devices, that is, one is magnetic disk, then solid state disk and magnetic tapes. The first one is magnetic disk. The process of magnetization is used to write, rewrite and access data on a magnetic disk, a storage device. This process is known as magnetic disk. It is coated magnetically and has tracks, spots and sectors. In 1956, IBM created the first magnetic hard drive, a substantial device with 50 to 21 inches platters. The basic common example of magnetic disk are floppy disk, hard disk and zip disk. The second one is magnetic tapes. Magnetic tapes were frequently utilized for secondary storage. Today they are in. It might take a while to get a specific location on a magnetic tape, but once reading or writing starts, access creates or and bar with disk drives. Mostly used for the it is also mostly used for the magnetic backups. Then disk scheduling. Disk scheduling algorithm determine the order in which the read or write head of the disk moves to access data, which impact the efficiency and speed of accessing data. Some commonly used disk scheduling algorithm include first come first serve, shortest seek time first and scan. The types of disk scheduling algorithms. First one is first come first served. The first come first serve algorithm is the simplest disk scheduling algorithm in which the requests are proposed in the order they arrive. It is a non-preemptive algorithm that does not take into account the distance between the current request and the next request. The second one is shortest seek time first. The shortest seek time first algorithm process the request with the shortest seek time. That is the request that require the least amount of movement by the disk head. This algorithm can minimize the head movements, but it may result in starvation of some request. The third one is scan. The scan algorithm processes the request in a specific direction, either from the innermost track of the outermost track or vice versa. After reaching the end of the disk, the head reserves directions and proposes the request in the opposite direction. This algorithm provides a balance between the number of requests processed and the time each request is wait. The types of scan is C-scan. The C-scan algorithm is similar to the scan algorithm, but the head moves only in one direction and process requests only in that direction. That is the concept of C-scan. The look algorithm is similar to the scan algorithm, but the head reverse direction when it reaches the last request in the current direction. This algorithm can reduce the waiting time for requests that are close to the head's current position. The next one is C-look. The C-look algorithm is similar to the C-scan algorithm, but the head reverse directions when it reaches the last request in the current direction. This algorithm can reduce the waiting time for requests that are close to the head's current position and eliminate the possibility of starvation. Thank you.